Particles projected with speed 7 root 5 and angle tan inverse 2. Nobody likes inverses, so tan A equals 2. This means 2 over 1, which means this side is root 5. This means cos A is 1 over root 5, and sine A is 2 over root 5. Okay, next thing. Says inclined plane of tan inverse 1 over 2. So I'm going to let tan B equal 1 over 2. Now tan B equals 1 over 2. That's the exact opposite. So that's 1, that's 2, and that's root 5. This means that cos B is 2 over root 5, and sine B is 1 over root 5. Okay. Now that you got all that out of the way, just sort of group all this together. You're just going to need it later on, so group it all together. Forget about it. It's up here. Okay. Now you have your slope like so. Make sure your diagram is large. Don't try to fit it in onto a small piece of paper. Now that's B. Now let's sort out the angle here, the A. So the A is over here, and this is going to be. We know this speed is 7 root 5. So this is going to be 7 root 5 sine A. What is 7 root 5 sine A? It's 7 root 5 multiplied by 2 divided by root 5. So what do you think it is? 7 root 5 multiplied by 2 over root 5 with 14, yeah. So change that to 14. That's 14. What do you think the other one is? The other one's going to be 7. It's going to be half it, isn't it? Because this is 2 root 5 and the other one's 1 root 5. So you have 7 and 14 straight away. Makes the job a lot easier. Next thing we're going to do is our gravity triangle. Do down here. Make it nice and large. Perpendicular and parallel. There you go. This angle here, B. All right, and then we have G is the hypotenuse. So this one goes diagonal down, diagonal right down, and diagonal left down. Now, what do we have here? E. So it's going to be 2 over root 5G. And the other one's going to be 1 over root 5G. Because it's G cos B and G sine B. So they're sorted already. Now, next thing we're going to do is set up our 4 equations. Use your reasonably easy. So phi x, lads. Killian, what's phi x?
7 root 5.
No, just 7.
Oh, yeah.
Because it's the phi x position. So 7.
And then
Take plus AT.
it's 2 over, or 1 over root 5G.
Yeah, minus 1 over root 5G. T. Phi y. That's it.
7 root 5.
Now, see the 14?
Yeah.
14 is in the y direction, so we're going to start off with 14. And then what else? Yeah, 2 over root 5 gt. Excellent, right. Now that you have the two, then the sx is easy to do. 7t minus a half, whatever this is, so it's 1 over 2 root 5 gt squared. Sy is 14t, and then half that, so half of 2 root 5 is going to be 1 over root 5 gt squared. Now and only now do I read the question again. I'm going to go back up the top and read the question, see what I'm actually meant to do here. Alright. Show that the time taken for the particle to reach its greatest perpendicular height above the horizontal and above the plane are in the ratio 4 is 3. Greatest perpendicular height above the horizontal and above the plane and the ratio 4 is 3. Alright, now this is an interesting one. Anybody get this one out last night? During the night? So Connor, what way did you tackle this?
I made like 8 equations.
Yeah?
That one for the kind of if it was going on to an inclined slope and one of the slope wasn't there.
Alright, gotcha.
And then I found out the greatest height.
Oh, nice. So he did it as if it was on horizontal.
Yeah.
So you just added the two angles together.
Yeah.
And you did it as if it was on horizontal plane. That's excellent. And the other way is you just do Vy equals 0, was it? And then get the distance above the axis. Yeah. Alright. So let's start off with the second one first, alright? Show that the time taken for a particle to reach its greatest perpendicular height above the horizontal and above the plane. So they're two different things. So if I take, yes, Connor?
Isn't A there the what's called that time minus 1 2 is above the horizontal, not the plane?
Oh, to the horizontal. Ouch, you're right. It is to the horizontal. So the particle's projected with speed 7√5 at angle tan inverse 2 to the horizontal. Yeah, so that means we're actually going to have to adjust that further. Fine. Up the line of grays implied and then tan. Yeah, you're correct about that. Alright. So, yep. So lads, here's what we're going to do here. Alright. So this means all this here. Just going to get rid of that part for a second, okay? The gravity triangle is perfect. So, what Connor said is, see this angle A? This angle A actually covers. This angle A is actually from here to here. See what I'm saying? Why is it like that? Because it says to the horizontal. Horizontal means the flat line, alright? So technically this angle in here is actually A take away B. Ever caught that? A take away B. Now, makes things slightly more difficult. There's rules. We could do it like that. Yeah, I can try it that way. Alright, have an idea for you. So, see the 7√5 down here? Right? Just makes everything slightly more complicated. Jeez, I didn't think there was one this hard early on. But there we go. There, I did do A. It's not A, it's A minus B. Okay. Now, let me see if I can remember this off by heart. There's a formula, you're going to need to know it. You'll know it eventually. Cos A minus B is cos A sine B. Cos A sine B. Who's got their tables out? Anybody have tables on them? Page 14. I just need two formulas, obvious. Okay. So I need cos A sine. I need cos A minus B and sine A minus B. Is that on page 14? There we go. Yeah. Cos A cos B plus sine A sine B, is it? Yeah. You'll be very familiar with these by February of this year because you're going to be doing them in February or March of this year because you'll be doing trig after Christmas, okay? Then sine A minus B is sine A cos B. And then what else is there? Minus cos A sine B. Now, what I can do with this is I can find out the value of cos A minus B, and I can find out the value of sin A minus B. You get what I'm saying? I could use a placeholder variable if you really want. I could say that this is, I could say let any letter from choosing. Let x equal A minus B. Okay? So let x equal A minus B, and I can just say this is sin x instead. And then this becomes cos x and sin x. Is that right? Whatever way you want to think of it. Now, either way, I'm going to have to put in all the numbers I got earlier into this, and I'm going to find myself a nice, I'm going to find myself a, I'm going to find myself some, I'm going to find myself the value of cos x and sin x, right? Very easy. Ready again now, Connor. Showing the deep end there. Alright, so let's find out what cos A and sin A are. So cos A is 1 over root 5 and sin A is 2 over root 5. So 1 over root 5 and 2 over root 5. And then the other one is cos B and sin B. Cos B is 2 over root 5 and sin B is 1 over root 5. So cos B, 2 over root 5, and that's 1 over root 5. Is that a 2/5 plus 2/5? You get me? 4/5. Oddly enough, you don't even need to do the other one now, do you? Because Pythagoras' theorem will tell you it's 3/5, won't it? But look, just for argument's sake, what's sin A again? Anybody? 1 over root 5. Yeah, cos B, 2 over root 5. Wait a second. Sin A is, no, they're both 2 over root 5. Has to be 3/5. Otherwise, you've gone wrong. There you go. And now it's, we're happy with 3/5. Right. What did we say the speed was earlier? What did you say? What? 7 roots. Right, so 7 root 5 is the speed. So it's going to be 7 root 5 cos A and 7 root 5, sorry, 7 root 5 cos x and 7 root 5 sin x. Does that make sense? 7 root 5 cos x, 7 root 5 sin x. Okay with that? Alright, so here's what we're going to do there. 7 root 5 times, anybody 7 root 5 times 4 over 5? What's 28 root 5 over 5, or 28 over root 5? What did they give you in the calculator? 28 over root 5? Alright. So, plug in 4/5, then you get 28 over root 5. And then sin x is going to be 3 over root 5, so that's going to be 21 over root 5. Ready? Now I'm done with all this nonsense. I don't need it anymore. Okay. There's other ways of doing it, but the other ways involve rounding off decimals and stuff like that. That's precision with fractions and thirds. There's no rounding off, so it's much more precise. Okay. Now let's go back up here. Now, what do I put in instead? For Px, sorry, for Ux, I'm putting 28 over root 5, and for Vy, I'm putting 21 over root 5. So let's go back here. Work's not lost. So 28 over root 5, 21 over root 5. 28 over root 5. Finally, 21 over root 5. Okay. Now, what I'm going to figure out here is, I'm about to figure out what is this distance here. Here to here. Everybody cool with that? That's the greatest height above the slope, or above the plane. That's the one I'm figuring out. I'm not figuring out the green one yet. I'll do the green one next. Okay? So let's keep going. So, what we're going to do is Vy equals 0. And then we're going to lob that into sy. Okay. Yes,
You also get the
I'll just need the times, do I? Awesome. Show that the time's taken. I don't even need the distances. I actually just need the time. Show that time's taken. Excellent. I'm surprised it's not the distance, but there you go. All right, fair enough. So, what we're going to do is we're going to find out the t value for your greatest height above the plane. Okay, so it's 21 root 5 equals 2 over root 5. 2 over root 5 gt. Okay, cancel the root 5s. We're probably going to, we don't need to cancel the g. I imagine the g will cancel with the other g. So that's no big issue. So it's going to be 21 over 2 g equals your time. Everybody cool with that? Now, the next thing we're going to do is we're going to pretend that the plane doesn't exist. Plane simply doesn't exist. Okay. So we're going to get rid of all this, and we're going to go back to what we learned in chapter 3. What do we know about chapter 3? Huh? Horizontal plane. So none of this exists at the moment, and we're all very happy with it. And then all of a sudden, if I go on, that was the point at which it was the highest above the plane, but you could still go slightly higher, and maybe it's this time here. Actually tells you in the question, doesn't it, that it takes longer to reach that height than it does the height above the plane. Okay, so they're two different times. Okay, so instead of a minus b, we actually just have a, and that is, this is 7 root 5, is it? Okay, so it's going to be 7 root 5 cos a and 7 root 5 sine a, and we have their values up there, don't we? That's going to be 7 and 14, because both of them, that's going to be 1 over root 5. That's going to be 2 over root 5. I'm just going to double check that. Yep, I'm all good. So 7, so it's going up at cross of 7 and up at 14. Now we're going to do our regular horizontal maths. So what's Vx in this case, lads? Killian, Vx, horizontal plane, plus 7. Done. Vy, 14 minus. Gravity only acts on the 14, it doesn't act on the 7 because they're perpendicular to each other. Okay? Perpendicular forces do not act on each other. And then Sx, yeah, and Sy, yeah, minus a half squared. Awesome. Now, what we're going to do next is, once again, Vy equals 0, because at the greatest height above ground is Vy equals 0. The Vy is different than the last Vy because you're talking about different directions, okay? So we're going to get a t equals 14, t equals 14 over g. Alright? Now, what's the ratio? 4 is to 3. I think I'm going to get, oh yes, I see it now. Alright, what do I multiply this one by, top and bottom? If I multiply by 2, what will happen? 28 over 2g compared with 21 over 2g. Cancel out the 2g's and divide both sides by 7. And you get a ratio of 4 is to 3. Thank Connor for the assist there. Good man.